So this is the next question. Observe this. So read this question. In a given network shown in figure, a steady state is reached with the switch K is open. Right? At t is equals to 0, the switch is closed. Okay? Determine the value of I1, I2, I3 at t is equals to 0 plus. See, he has given that. So with the switch K is open, it is the circuit is in steady state. It is given. Or otherwise, if we not given also, it can be visible. Because if the switch is open also, the 6 volts source is connected to inductor and connected to capacitors. Right? So, for any circuit consisting of inductors and capacitors, first of all, for finding the transients, currents or voltages, okay, first of all what we have to do, we have to observe what is the circuit in t is equals to 0 minus and what will be the circuit and t is equals to 0 plus. Okay, so and t is equals to 0 minus and t is equals to 0 plus, we will find the voltages and currents in the inductors and capacitors. Okay, so that is the thing you have to observe this. Okay, so now, so this is the circuit. So because the circuit is in steady state, okay, at t is equals to 0 minus, the circuit is in steady state. Because see, at t is equals to 0, the switch is closed, but before that only, the circuit is in steady state. It is given this. Okay, because even though the switch is not closed, okay, the 6 volt source is connected to capacitors and inductors, so that's why we can say that the circuit is in steady state. Okay, so in steady state, what we can write? In steady state, what happens? In steady state, the inductor is short circuited and capacitor is open circuited. This is the point you have to understand. Okay, so at t is equals to 0 minus, how the circuit will be? The circuit is in steady state. Okay, the circuit is in steady state. The circuit is in steady state. Right? So the circuit is in steady state. Then how can we write? Now I am drawing the circuit in steady state condition. So 6 volt source and one resistance. Now one resistance here. Here what happens? In the steady state, the capacitor is open circuited. So that's why I write this. Okay. Here one switch is there, but the switch is not closed. Right? Switch is there, the switch is not closed. And here one more inductor is there, but that inductor is short circuited. Here one capacitor is there. This capacitor is open circuited. Let us suppose, what is this capacitor? This capacitor C1 is equals to 0.5. It is C2 is equals to 1 farad. 0.5 farad, 1 farad. These are open circuited. Okay. What is this? This 1 Henry inductor is, what happens? It is short circuited. So this is the circuit at t is equals to 0 minus. Okay. This is 6 volt source. It is 2 ohms. It is 4 ohms. Okay. Like this. Now what we have to find? We have to find the current in this. So I1, I2, I3 in this loop. Okay. We have to find the I1, I2, I3 at t is equals to 0 plus. But this is a circuit at t is equals to 0 minus. Okay. Because it is in steady state. Observe this. See what is the current in this? What is the current? See, the current is coming like this. Okay. But the current in this is 0, means I2 is 0. The current in this is 0, means I3 is 0. Now what is the current? The current will flow like this and flow like this and flow like this. This is I1 in this loop. Okay, I1 is the current in the first loop. Now what is I1 of 0 minus? What is the current I1? I1 is nothing but the current through the inductor only. Okay, the current through the inductor only. So from this, what we can write? So I1 of 0 minus is equals to, how much it will be? 6 divided by, it is the loop, right? 6 divided by 2 plus 4. It is 6 divided by 6. It is equals to 1 ampere. It is 1 ampere. Right? So I have calculated the current through this. Okay, the current through the inductor. The current through the inductor. This is 1 ampere. Now, what is the, see, observe this. If it is 1 ampere current is flowing in this, now what is the voltage across this? The voltage across this will be, it is 6. 1 ampere current is flowing. So 1 into 2, it is 2 ampere is dropped, 2 volts is dropped here. So 6 minus 2, it will be 4. Okay, or otherwise you can also write, this is 1 ampere current is flowing, right? If 1 ampere current is flowing, what is the voltage across this? The voltage across this one is 4 volts, right? So it is the 4 volts. What is this? It is 4 volts. What about this? It is 0 volts. Because it is short circuited, so from here to here is 4 volts. The voltage across this one is equal to voltage across this one, right? So now, what is the voltage across this VC1? Means the voltage across the capacitor 1 and voltage across the capacitor 2. Okay, what will be this? How much it will be? So this 4 volts is, see, it is open circuited means, the capacitor is open circuited means it is fully charged. Maximum voltage is reached there. Okay, fully charged means, now out of this 4 volts, how much, see, out of this 4 volts, how much is voltage is applied across this, how much voltage is applied across this. So that means this 4 volts is divided in this capacitor and this capacitor, right? So now at VC of G1 0 minus is equals to, it is, how much it will be? It is 4 into, write the voltage division principle for the capacitors. What will be the voltage division principle? Voltage division principle for the capacitor is equal to 4 into opposite resistance, opposite capacitance divided by the total capacitance. So it will be 1 farad divided by 1 divided by 1.5. This will be, it will be 1 divided by 3 by 2. 2 by 3. This will be 8 by 3 volts. 8 by 3 volts. This is VC1 of 0 minus. Now what will be the VC2 of 0 minus? VC2 of 0 minus will be total voltage. It means 4 into opposite capacitance divided by the total capacitance. This will be 0.5 divided by the 1.5. 0.5 divided by the 1.5 means it will be 0.5 divided by the 1.5. This will be 4 by 3 volts. So this is the VC1 of 0 minus, VC2 of 0 minus. We have calculated the voltage and currents. What we have calculated? The current through the inductor at t is equals to 0 minus and voltage across the capacitor at t is equals to 0 minus. Right? So these are the things. Now at t is equals to 0 plus, at t is equals to 0 plus, at t is equals to 0, the switch is closed. At t is equals to 0, the switch is closed. So if the switch is closed at t is equals to 0 plus, what happens? What will be the circuit? The circuit will be like this. The circuit will be like this. Because at t is equals to 0, the switch is closed, right? Now how the circuit will be? The circuit will be looking like this. Okay? So this is a resistor. Now what about this? At t is equals to 0 plus, what happens? At t is equals to 0 plus, the inductor is energized, right? The inductor is energized. Okay? If the inductor is energized and capacitors are also energized. So at t is equals to 0 plus, the energized inductor, energized capacitors are there. So at t is equals to 0 plus, inductor is, which kind of inductor? This is the energized. Why it is energized? In t is equals to 0 minus also, the current is existing. That's why it is called as energized inductor. At t is equals to 0 minus also means, even though the switch is not closed, the capacitor is having some voltage, initial voltage. Okay, so that's why these two are called as the energized capacitors. So whenever there are energized capacitors, okay, whenever there are energized capacitors or inductors, at t is equals to 0 plus, what it will be? The inductor is replaced by the current source and capacitor is replaced by voltage source. This is the point you have to understand. At t is equals to 0 plus, the inductor acting as a current source and capacitor acting as a voltage source. Okay, so this is the point you have to notice. So this is what? This is one switch is closed here because the switch is closed. Okay. Here what happens? At t is equals to 0 plus, I am drawing this. Now this inductor acting as one current source with the same direction. Okay. With the same direction. The current is how the current is. The current is flowing in this direction, right? You have to take that direction only. Okay. It is a 1 ampere current source. Now what about this capacitor? What about the capacitor? The capacitor acting as a voltage source with what voltage? 8 by 3 volts. So this capacitor acting as one voltage source of 8 by 3 volts. Right? So here what happens? This will be acting as voltage source of how much? 4 by 3 volts. It is 4 by 3 volts. Now this is the thing. Now this is how much? It is 4 ohms. It is 1 ampere source, 8 by 3 volts. It is 4 by 3 volts. This is 2 ohms. It is 6 volts. Okay. Now I have drawn the t is equals to 0 plus. This is the circuit. Now what we have to find? We have to find I1, I2, I3. Okay. At t is equals to 0 plus. Okay. So now if you observe this, what is this I1? I1, I2, I3. I1 means what? The current through the inductor. So at t is equals to 0 plus also, it is having 1 ampere only. So we can say that what it is? I1 of 0 plus is equals to I1 of 0 minus is equals to how much? It is 1 ampere only. Right? Okay. So now see, at t is equals to 0 minus, at t is equals to 0 minus, what is the voltage across the capacitor? The voltage across the capacitor is 8 by 3. But it is equivalent to the voltage across the capacitor at t is equals to 0 plus also. It is also the voltage across this capacitor is before at t is equals to 0 minus is 4 by 3. But it is equivalent to the voltage across the capacitor at t is equals to 0 plus also. So these are the voltage sources. Right? These are the voltage sources. So at t is equals to 0 plus, it is acting as a voltage source. It is also acting as a voltage source. Right? So what is the total voltage? The total voltage is 8 by 3 and 4 by 3. It is 12 by 3 means it is a 4 volts. So it is having 4 volts at this point with respect to this. Okay? It is 0 volts. Right? 4 volts at this point. So if it is 4 volts, now what is the current in this? The current in this is 6 minus 4. 6 minus 4 divided by 2. So it will be 2 by 2. It is 1 ampere is current is flowing. So how much current is flowing? 1 ampere current is flowing in this. At t is equals to 0 plus. This is the total current. Right? So now what is this? It is 4 ohms, right? It is 4 ohms. Right? It is a 4 ohm. Now so now what happens? So this 8 by 3 volts is appearing across this. If 8 by 3 volts is appearing across this, now what will be the current in this? The current in this is 8 by 3 divided by 4. This will be 8 by 3 divided by 4 means it is 2 by 3 amperes is flowing in this direction. 2 by 3 amperes is flowing in this direction. Right? So this is 1. It is 1 ampere is coming. It is 2 by 3 is coming in this direction. Now what will be this current? This current will be, it is 2 by 3 means it will be 1 by 3. Right? So if you observe this, what is this current now? Already we know what is this current. This is 1 ampere. Now what will be the current? The current will be this 2 ampere and 1 by 3 ampere. These two are coming and coming in this direction. This 2 by 3 amperes, it 1 by 3 amperes is coming like this. But what is the current? It is 0 amperes. Right? The current is 0 amperes. So 2 by 3, 1 by 3. 1 by 3 is going in this direction. Right? The 1 by 3 is going in this direction. This is 1 by 3. So 1 by 3 amperes is going in the switch. But there is no current in this direction. So 2 by 3 plus 1 by 3 is 1 ampere. So this is the thing you have to understand. So this will be equals to what? This will be is equals to, so I1 of 0 plus is equals to how much? I1 of 0 plus is equals to 1 ampere. So I2 of 0 plus is equals to, this is I2, it is 1 by 3 amperes, right? Now I3 of 0 plus is equals to 0 amperes. This is the current, right? So what is the option? Option here is option A. Option A is the answer, right? So this is a very good question. See what we have observed in the steady state. Inductor is acting as short circuit, capacitor is acting as open circuit. So before the switch is closed, the source is connected to the inductors and capacitors. So that's why, so before the switching operation takes place, the inductors and capacitors are energized. Okay, the inductors and capacitors are energized. So in this we calculated the inductor current and capacitor voltage, and this same will be equal to the t is equals to 0 plus also, but instead they are inductors and capacitors are, what happens? Inductors here they are short circuited and capacitor is open circuited, but at t is equals to 0 plus, the inductor is acting as a current source and capacitor is acting as voltage source. So this is the thing, right? So after that, this is a voltage source, right? Now the switch is closed. Now it can be equal to this. Now this can be equal to this. The voltage across the current source, this inductor at t is equals to 0 plus will be, how much it will be? It is 1 ampere. Okay. Now sometimes you may ask like this also. So now what will be the voltage across the inductor at t is equals to 0 plus? Suppose if we ask VL of 0 plus, how much it will be? VL of 0 plus is this one only. It is connected to this. So it is equals to 4 by 3 volts. It is the VL of 0 plus. Now suppose if he has asked IL of DIL of divided by DT of 0 plus, how much you can, how will you calculate? Suppose he has asked DIL of 0 plus divided by dt. How can you calculate? So in this question, suppose if it is asked like this, okay, how we have asked DIL of 0 plus divided by dt. We have to find the rate of change of current in the inductor at t is equals to 0 plus. How can you calculate? So at t is equals to 0 plus, what is the voltage? At t is equals to 0 plus, this is the voltage. So VL of 0 plus is equals to L into DIL of 0 plus divided by dt. This is the point you have to understand, right? DIL of divided by dt. VL is equals to L into di by dt. Already we know this is how much? 4 divided by 3. This is equal to L is how much? L is how much? 1 Henry. 1 into DIL of 0 plus divided by dt. So this implies DIL of 0 plus divided by dt is equals to how much? It is 4 by 3 ampere per second. So this is the answer. So he may ask like this also, right? So this is the thing you have to identify. So sometimes he may ask the rate of change of current in the current at t is equals to 0 plus. So this is the thing, right? So like this also you can find. Now similarly he may ask the rate of change of voltage, in VC1 also. Suppose if he has asked VC1 of 0 plus, suppose he may ask dVC1 of 0 plus divided by dt. How will you calculate? How much it will be? What we have to find? To find the rate of change of voltage in the capacitor at t is equals to 0 plus. How can we calculate? So how much it will be to find the rate of change of voltage in the capacitor? What we have to find? You should know the current in the capacitor. So already you know the IC is equals to C dVC divided by dt. But you have to find the IC of 0 plus. Suppose if I want to find the current in the IC1, C1. Okay, this is IC1 of 0 plus. This will be C into dVc of 0 plus divided by dt. Okay, so this is the thing. This is Vc1. Now what is the current in this capacitor? The first capacitor is 1 by 3 at t is equals to 0 plus. So this will be equals to, what is the capacitor value? Capacitor is 0.5. Now what is the dVc? dVc1 of 0 plus divided by dt. This is the thing. So dVc1 of 0 plus divided by dt is equals to 1 divided by 3 into 0.5. This will be 1 by 2. 1 by 2 means it is 2 by 3 ampere per. This is volts per second. It is volts per second. It is 2 by 3 volts per second. Right? So like this, you can calculate this. Right or not? So this is the question. Next question. If you observe this question, so one circuit is given and switch is placed here. At t is equals to 0, the switch is going to be closed. Now he asked us to find the IL of t for t greater than 0. Okay, the inductor current for t greater than 0, he is asking. So for finding IL of t for t greater than 0 is equals to I final minus I initial. I initial means 0.0 plus, I of 0 plus, okay, into e power minus t by tau. E power minus t by tau, where tau is the time constant. So this is the thing you have to remember this. Similarly, you should also remember this. Vc of t is equals to V final minus V initial. Vc of infinity minus Vc of infinity minus Vc of 0 plus into e power minus t by tau. Right? So this is the thing. These are the two expressions you should remember forever. Okay? While dealing with the transients. So what is this I final, I initial, V final, V initial? I final means the steady state current. I initial means the initial current. Okay? So if you observe this question, he is asking us to find the IL of t greater than 0. So mostly you will get these kind of questions. Okay? See, observe this, how to proceed for this. So for finding IL of t or Vc of t any circuit, first of all you have to go to the t is equals to 0 state. T is equals to 0 minus state. Okay? So just before switching, you have to observe the circuit. Okay? And after that, at t is equals to 0 plus, you have to observe that circuit. And after that, you have to go to the t is equals to infinity state. Okay? In steady state. So you have to check the circuit for three conditions. First of all, you have to go for before switching, and next immediately after switching, next at the steady state. So for each and every question you have to go for that. And first at t is equals to 0 minus, you have to find all the possibilities. The capacitor voltages, t is equals to 0 minus, okay, inductor currents like that, and inductor voltage and inductor current also. Okay, inductor voltage and capacitor current also. Okay, it is better to find all the voltages and currents. Okay, so if you observe this, one RL circuit is given here. Okay, see what he is asking. He is asking us to find the IL of t at t greater than 0, t greater than 0, right? So for this, first of all, what we have to do? First of all, we have to go to the t is equals to 0 minus condition. At t is equals to 0 minus means just before switching. So the circuit will be in steady state. How the circuit will be? The circuit will be looking like this. It is 36 volts. It is 12 ohm. It is 6 ohms is connected. Right here 6 ohms. And if it is in steady state, what happens? The inductor will be short circuited. Inductor will be short circuited and capacitor is open circuited. Okay, in the steady state, the inductor is short circuited, capacitor is open circuited, right? So this is like this. Now this is the inductor is short circuited, right? The inductor is short circuited. Now how much it is? It is 12 ohms. It is 6 ohms. Write this. Right? Now what we have to find? We have to find the IL of 0 minus. What will be the IL of 0 minus? This is the IL of 0 minus. This IL of 0 minus is equals to how much? So this is 36 volts. It is 36 volts. It is 12 ohms, 12 ohm. So how much we are getting? IL is equals to IL of 0 minus is equals to, this is the current is going like this, right? So 36 divided by 18. So this will be equals to 36 divided by 18. So this will be 2 amperes. So IL of 0 minus is 2 amperes, right? Now you know this IL of 0 minus is equals to IL of 0 plus, right? Okay, so write the T is equals to 0 plus, what will be the circuit? At T is equals to 0 plus, what will be the circuit? The circuit will be like this. At T is equals to 0 plus, I am writing this. See, this is closed, the switch is closed, and here, this is how much? It is 12 ohms, it is 6 ohm, it is 6 ohm, okay. What is this? It is 6 ohm. But at T is equals to 0 plus, the inductor is equals to what? It is replaced by one current source. So this is IL of 0 plus. How much it is? IL of 0 minus is equals to IL of 0 plus, right? So this is equal to IL of 0 plus, right? Now in T is equals to 0 plus, the inductor acting as a current source of how much? A current source of 2 amperes. A current source of 2 amperes. But it is not required to us. It is not required for us. But what we have to find? We have to find already, we know this is IL of 0 minus is equals to IL of 0 plus. Already one thing is calculated. So no need to write this. But just now, just I am recollecting you. But this is how much? It is 36 volts. Okay? This is at T is equals to 0 plus, but it is not required. Just you should know one thing, that IL of 0 minus is equals to IL of 0 plus, right? So this is the point you have to understand. Now in study it at T is equals to infinity, means final state. How the circuit will be? The circuit will be looking like this. See, it is closed circuit, right? So at T is equals to infinity also, that is the switch is closed, right? So this will be 36, one resistor. This is short circuited, and here is one more resistor. It is 6 ohm, it is 12 ohm, it is 36 volts. So this is 6 ohm, and again it is short circuited, right? This is IL of infinity, right? This is IL of infinity. So this is the thing, right or not? So this is the circuit at T is equals to infinity. So now what will be the IL of infinity? IL of infinity is equals to, so this is how much? It is 6 ohm, right? So what is this IL of infinity? How can you find the IL of infinity? See, this is a 6 ohm, this is a 6 ohm. This is short circuited. That's why the 6 ohms are in parallel. So the parallel combination of these two will give you 3 ohm. Okay. So this entire thing is 3 ohms. So if this entire thing is 3 ohm, means it is 12 ohm plus 3 ohms. It is 15 ohms, right? 12 ohms plus 3 ohms is 15 ohms. Now what will be this current? This current will be, how much this current? This current will be, this current is how much? This current is equal to 36 divided by 15, right? This is 36 divided by 15. How much it is? 36 divided by 15 is, it is 2.4 amps. It is 2.4 amps is coming in this. If the 2.4 is coming, now it is 6 ohms, it is 6 ohm. Because these two are in parallel, this is 1.2 ampere, this is 1.2 ampere, right? So IL of infinity can be written as, it is how much? It is 1.2 amperes is coming. Okay. So now IL of infinity is calculated and IL of 0 plus is also calculated, right? Now what is the thing remaining? We have to find the tau. For finding the tau, how can you find the tau? Okay, time constant. How can you find the time constant? The time constant is found after the switching takes place. Okay, it is calculated after switching. Okay, always the time constant is calculated after the switching. So for finding the time constant, observe this question. So this is the original question. So switching is done. So the switch is closed here. This is 6 ohm. It is 12 ohm. It is 36. Now it is 6 ohm. Now in which we have to find the current that must be considered as a load. Okay. So this is the thing, you have to remove that load. What is that load here? The inductor is the load. Okay, inductor is the load. Now how can you find the R equivalent? So R equivalent is equals to, so what is the tau? For any RL circuit, the tau is equals to L equivalent divided by R equivalent. L equivalent divided by R equivalent. What is the L equivalent? It is only one inductor is given, that is the inductor 15. What is the R equivalent? R equivalent, while calculating the R equivalent, how can you find? So while calculating the R equivalent, how can you find the R equivalent? By deactivating the independent sources. Okay, by deactivating the independent sources. So for calculation, how can we find the tau? The tau can be calculated after the switching. Okay, so for that, what we have to find? We have to find the L equivalent and R equivalent. Okay, for finding R equivalent, what we have to do? Deactivate all independent sources. You know how to deactivate all independent sources. How to deactivate all independent sources? The inductor is the current source is open circuited and the voltage source is short circuited. Okay, the current source is open circuited and voltage source is short circuited. This is the thing. Okay, so while finding the R equivalent, we have to deactivate this. I have to deactivate this, means this is a voltage source. I have to deactivate this. Now find the R equivalent. R equivalent is equal to, so this is deactivated, right? So there must not be any independent sources in the circuit while calculating the tau, right? So this is 12 and 6. These two are in parallel now. So these two are in parallel. This parallel combination is series with how much? It is 6 ohms. So R equivalent is equals to how much? It is 12 into 6 divided by 12 plus 6. 12 into 6 divided by 12 plus 6, how much you will get? 12 into 6 divided by 12 plus 6, it is 12 plus 6 is 18. 18 means it is 12 into 6 divided by 12 plus 6 is 18. Okay, it is 3. It is answer 4. Okay, R equivalent is 4 here. Here R equivalent is 4. Now what is L equivalent? L equivalent is 15 only. Only one inductance is given. So now what is the tau? Tau is equals to L equivalent 15 divided by 4. This is equals to 15 divided by No. This is equal to, what is R equivalent? R equivalent is, here R equivalent is equals to 66 plus 12 parallel with 6. This is equals to 6 plus, what is the 12 parallel with 6? 12 parallel with 6 is, it is 4. So this is 10 ohms we got. So R equivalent is 10 ohms we got. So now what is L equivalent? L equivalent is already given. It is 15 ohms. So 15 Henry. So L divided by R. R is 10. So this will be, it is 3 by 2. It is 3 by 2. So calculation of tau is completed. So now how can we find the How can we find? What we have to find? We have to find IL of t for t greater than 0. So IL of t for t greater than 0 is equals to, these two are for what? T greater than 0. These are for t greater than 0. So this will be is equals to I final. What is the I final? We got I final. I final is 1.2 minus I final 1.2 minus I initial. We got this 2 amperes. Okay, minus 2 into e power minus t divided by tau. Tau is how much? It is 3 by 2. Means it is 2t by 3. So the final answer is 1.2 minus it is plus 0.8. It is minus 0.8 minus of minus plus e power minus 2t divided by 3. So this is IL of t. Right? So like this you have to solve. So within 2 steps you can directly find. So how can you calculate? First of all, you go to the t is equals to 0 minus. If it is, see, without having this much, just I have explained in a detailed manner. So you can directly find the answer. See, observe this. See, first of all, what you have to do? You have to go for the t is equals to 0 minus condition. For t is equals to 0 minus condition, how the switch will be? The switch is open. So the switch is open. Now what will be the IL of 0 minus? What is IL of 0 minus? IL of 0 minus is 36. So this resistor will not be working. So 12 plus 6, it is 18. So 36 divided by 18. So IL of 0 plus, this is short circuited. Okay, this is short circuited because it is connected from minus infinity time, right? So this will be equals to 36 divided by 18. So this will be 2 amperes. Now at t is equals to infinity, okay, but it is equivalent to what? It is if IL of 0 minus is equals to IL of 0 plus. This is the thing you should understand. Okay, so the current in the inductor just before switching is equals to just after the switching. Okay, at t is equals to infinity, now what happens? The switch is closed. At t is equals to infinity, the switch is closed. Right? So if the switch is closed now what will be the t of IL of infinity? If IL of infinity, now what happens? At t is equals to infinity, the inductor is also short circuited. Okay, if the inductor is short circuited, what happens? This 6 into 6. The 6 into 6, the 6 is 6 into 6 divided by 6 plus 6. Right? These two are the parallel combination. So this will be 3. Okay, this is 3. So 12 plus 3 is 15. So the IL of infinity will be equals to 36 divided by 15. This will be 1.2 we got, I think so. Okay, 1.2 we got. Right, 36 divided by 15. So you can directly write the formula. So before writing the equation, you have to find the time constant. So what will be the time constant? For finding the time constant, you have to open circuit. You have to open circuit the terminals at which we have to find the response. Okay, we have to find the current through the inductor. Okay, so you have to open circuit the terminal. Okay, you open circuit this terminal. So you have to remove that inductor. Now we have to find the time constant. The time constant is calculated only after the switching. The time constant is calculated only after the switching. So while finding the time constants, you have to deactivate the independent sources. Okay, for finding the R equivalent, you have to deactivate this. You have to deactivate this. So deactivation means it's a voltage source, it must be short circuited. So these two are now what? Parallel combination. So the parallel combination of these two will get 4 ohms. So 4 plus 6, it is 10 ohms. So 10 ohms is the R equivalent. Now what is the L equivalent? L equivalent is this one only. How much? It is 15 ohm. So tau is equals to L by R. So L equivalent divided by R equivalent, this is equal to 2 by 3. So we can directly write the equation. Okay. So like this you can solve.